Biconditionals and definitions. Biconditionals. So we're talking two. When you say bi, you're talking two of something. So in this, we're going to look at the examples. These are insects. Insects have 3 body parts and 6 legs. That's what their definition in science is. Where these are non-insects. Spider, tick, centipede. Okay, so looking at the examples of insects and non-insects below, how would you complete the following sentence? If an animal is an insect, then what? Okay, and then explain your reasoning. In the solve it, you're using conditional statements. A biconditional is a single true statement that it combines a true condition and its converse is also true. So looking back on the last section, the converse was flipping it. You can write a biconditional by joining the 2 pairs of each conditional with the phrase if and only if. So that's important when we're talking about conditionals. Let's go to problem 1. Looking at problem 1, what is the converse of the following true condition? If the converse is also true, rewrite the sentence statement and it will be a biconditional. If the sum of the measure of 2 angles is 180, then the 2 angles are supplementary. Now we're going to write the converse of it, so the opposite. If 2 angles are supplementary, then the sum of the measures of the 2 angles is 180. Yes, that's true. That means you can form a true biconditional by joining the 2 conditions and the true converse with an if and only if. So that looks like this. 2 angles are supplementary if and only if the sum of the measures of the 2 angles is 180. What is the converse of the following true conditionals? That would say if the converse is also true, rewrite the statement as a biconditional. If 2 angles have equal measures, then the angles are congruent. Okay, so go ahead and do that on your own. Next, take some key notes on this. So when you write a biconditional, it combines the if, then, and the converse of it to mean if and only if. So if P, then Q. If Q, then P, such as P if and only if Q. For example, let's say a point is a midpoint if and only if it divides a segment into 2 congruent segments. So there's our if and only if. And that's how we write it as a symbol. So go ahead and look at these 2 down here. What are the 2 conditional statements that form a biconditional? A ray is an angle bisector if and only if it divides an angle into 2 congruent angles. Well, let's say that P is an angle bisector and Q represents a ray divided an angle into 2 congruent angles. So if I'm going to say if, with P as being my red, if a ray is an angle bisector, then Q, it divides an angle into 2 congruent angles. I can flip that with the converse and say if a ray divides an angle into 2 congruent angles, then it is an angle bisector. See where these 2 are flipped around and these 2 are flipped around. So P, then Q, or is it Q, then P? This means it's a true conditional. It can go either way. All right, go ahead and look at the problem, see if you got it, and rewrite a biconditional for that one. Let's go to problem number 3. We're going to take some notes on this. Writing a definition as a biconditional. If this definition of quadrilateral is reversal, if yes, write it as a true biconditional. So a definition is a quadrilateral is a polygon with 4 sides. So So first you write the conditional. If a figure is a quadrilateral, then it is a polygon with 4 sides. The converse of that, if a figure is a polygon with 4 sides, then it is a quadrilateral. So with the conditional and its converse are both true. The definition can be reversible, and you can write the conditional and its converse as a biconditional. So here's a biconditional. A figure is a quadrilateral if and only if it is a polygon with 4 sides. Okay, go ahead and try that with your sample, and then we'll go on to problem 4, identifying good definitions. So in this, which of the following is a good definition? A fish is an animal that swims. Rectangles have 4 corners. Giraffes are animals with very long necks. A penny is a coin worth 1 cent. Choice A is not reversible because a counterexample is a whale can swim. A whale is not an animal. A whale is an animal that swims, but it is a mammal, not a fish. Choice B, corners, is not clearly defined, so all quadrilaterals have 4 corners. In choice C, very long is not very precise. Also, choice C is not reversible because ostriches have long necks. Choice D is a good definition. It is reversible, so 1 cent is also worth, or 1 cent is also worth 1 penny, or the worth of 1 cent is equal to 1 penny. That is reversible. And all of the terms in the definition are clearly defined and precise. So the answer is D on that one. All right. Good job. Go ahead and start your practice problems on page 101.